Hello everyone, myself Raghuveer KOMBADE. I'm a third year civil engineering student from MIT Academy of Engineering, alandi. Today I'll be presenting on bridges. Starting with the introduction to bridges. A bridge, we could say, a structure that is specifically designed to provide a passage to the peoples to cross obstacles, physical obstacles, we could say, such as rivers, roads, railways, or any other depression. Heading towards the components of the bridges. Bridge components involves decks. Deck. Uh, the deck basically, we could say, a structure that serves the purpose of providing path to the peoples and serves the major or primary purpose of transportation. It is usually made up of uh, RCC or steel, which is supported on girders. Next component is a girder. Girder basically can be made up of either the steel or the RCC, and the girders in India usually are 30 meters uh, in span, and they support the deck and further transfer the load from deck to the piers. Heading towards the next component, which is piers and abutments. As I said earlier, girders transfer the load from deck to the piers, and further piers, which can be termed as a compressive members of a bridge, they transfer the load to the foundations. Next component is a foundation. Foundation can be uh, basically a square pad foundation or pile foundation. Foundation serves the purpose of transferring the load of whole bridge to the hard strata and spread it over the major area. Next, heading towards the classification and types of bridges. First classification is based on structure based. Next is material based, and there are some common types of bridges as well. Structure based involves beam type bridges, arch bridges, truss bridges, and suspension bridges. Talking about the arch bridges, there are two types. First one is under arch bridge and over arch bridge. The under arch bridge transfer the load through compression, and over arch bridge transfer the major load through tension. Next, suspension bridge is also the type. Next classification is based on material, which is first one is steel bridges. These types of bridges are majorly constructed through steel structures forming a frame such as trusses, and they can be usually hard to maintain. Next one is concrete bridge. Concrete bridge are most commonly used bridges, and next one is timber bridge, and after that there are some composite bridges as well. In terms of composite bridges, we can say the RCC and steel bridges can form a composite bridge, where half of the bridge is made up of RCC, and some of the part is made up of steel. This usually is used where it is there is a requirement of larger span between two pairs. They use the steel girders, and rest part is made up of RCC. Some common types of bridges are slab bridges, girder bridges, and cable stayed bridges. And lastly, suspension bridges as well. Further heading towards the key features and roles of bridges. First one is functionality. The bridge serves the functionality of transportation over the obstacle, as I said earlier. Next one is structural integrity. While providing the purpose of transportation, it is also necessary for a bridge to be structurally strong and serviceable. Next is aesthetic impact. Usually in metropolitan cities, aesthetic impact of the bridges is also an major component, we could say. And next one is durability. RCC bridges do resist much of environmental effects or atmospheric effects, while steel bridges require more of a maintenance for that specific purpose. Uh, Further, talking about the major components of a bridge, first one is superstructure. The that we could say the part which is above the ground. Next one is substructure, and lastly additional elements such as bearing and expansion units. Superstructure mainly involves decks, girders, trusses, which are above the ground. Next one is substructure. Substructure involves piers, abutments, foundations that support the superstructure. Lastly, elements that uh, additional elements which are bearings located between the girders and the piers, which serve the purpose when there is thermal expansion or lateral movement. They are specially designed for it. Next is expansion joints and railings to ensure the safety. Further, talking about the economical span in bridge design, the economical span mainly refers to the concept of cost and cost and the length of span optimization. Uh, Mainly, the balance between the cost and the structural efficiency can be defined as economical span. Mm, Economical span. Next is hydraulic considerations for the bridges. A flux is the part where, due to construction of bridges, the level of water rises on upstream side, which can impact the flow levels. That also needs to be considered. The next one is high flood levels, which is obtained from past 35 years of data, and the bridge span and the bridges height, which is determined through this criteria. Next one is scour depth. Scour depth involves the consideration for erosion due to flow of water, thus maintaining the structural or foundational stability. Otherwise uh, otherwise it may cause irregular settlement of the foundation, which may further cause the failure. And talking about the next part, which is loads on bridges. Loads on bridges involve dead loads, live loads, and environmental loads such as wind load, seismic activity, and temperature stresses as well, and in some areas snow effects as well. And next part is IRC consideration. um, Before IRC consideration, talking about the wind loads, bridges such as suspension bridges have higher fatality due to wind loads. Talking about the IRC loads. Now, IRC involves the three types of loading, which is class AA loading, class A loading, and class B loading. Uh, and IRC standards loading involves also there are two common types, which are IRC standard loading and IRC heavy loading. Standard loading involves 6 to 9 tons of load, and heavy loading involves zero point 0.8 tons of load per meter. Further, talking about the IRC class AA loading, this class basically correspond to IRC class 70 loading. By class 70, they mean that 70 tons of load can be considered for the design, and 30 meters to 90 meters span can be considered. Next loading is class A loading. For this specific type of class A loading, as per IRC, it is supposed to be designed for the worst axle conditions. First, class AA loading was designed for special condition with heavy loads, and this condition involves design for axle loads with worst combinations. Next one is class B loading. Class B loading. This class B loading is also similar to class A loading, but with lower loads. And further, talking about the common causes of bridge failures. First one, which is major throughout the world, which is corrosion, and mainly seen in steel bridges. Next is wear and tear due to the action of water or wind in some cases. And one of the common parts which is failure due to excessive loading can be also seen. Uh, Concluding to the today's presentation, we can say comprehensive design, which involves the balance between the load, cost, and we could say the span length. Next is sustainability, which involves the use of eco-friendly materials. Next, further, which is innovation, which can be introduced. For example, one of the innovations that is being used in foreign countries is the span which is between the two pairs. It is 120 meters, and currently in India, it is not more than 60 meters being used, uh, and it is a new concept which is being introduced. And next part is maintenance involves regular inspection to prevent failure and extend the lifespan of bridges, also preventing the extra costs.